Hello everyone. I hope everyone's safe. My name is Srinivas Lutkori. The presentation is for Capstone Project Data 606. My project title is Text Tagging Using NLP. A quick recap about my project. The dataset which I'm using for this project is News Aggregator dataset. It has more than 400,000 rows with 8 columns. So the dataset is from March of 2014 to August of 2014. That is a span of 6 months. So my main columns are category, title, web link, and Unix time. So I found some of the patterns and seasonalities in delivery 2 and delivery 3. So along with that, exploratory analysis, and I did some text data and text cleaning. So project aim, finding patterns and seasonalities in the dataset and to categorize, and the third one to actually retrieve the article and use it for comparison and similarities. So literature review and industry research. Text data has huge impact on big data industry right now. Uh, it has huge number of use case scenarios like there's structured data, unstructured data, semi-structured data in cloud, and valuable insights can be drawn from this type of data. So there are similar projects to my project, but everything is done in text mining and text data. So the goal of my project is to achieve 70 to 80%. So the insights can be a little fluctuating, but with correct procedure and questions, I think we can get some reasonable insights. So continuing into my exploratory analysis, the left side pie chart, which you can see is based on my category. So E is entertainment, M is medical, B is business, T is science and technology. So you can see that entertainment dominates all the sectors. So it's more like it creates trend, and most of the publishers post articles on that. So on the right side, you can see that these are the top 5 magazines and the number of posts. So this is actually a valuable insight because this just determines the advertisement prices, the reach, and everything. So this graph is based on every category in every month. So it's more like entertainment is leading in April, and it got down in May. So medical had a boost in like April and May, but it got down in June and July. So it can bring some insights. So it's more like entertainment is more in April because Game of Thrones, a season got premiered, so that is why it has more number of posts about this. So after the exploratory analysis, text cleaning is to be done prior to any visualizations or anything for text data, as text data has too many like stop words, punctuations. So without that, without like removing that, you don't get like accurate results. So in the text data, we're gonna remove punctuations. We're gonna take out stop words, remove the numbers from the text data because Airbus 800 is like you don't have to like mention 800 instead of that. You can just mention Airbus. So that creates like a category. We're going to change everything into a single case format just to uh, what do you say, delete the multiple words. So after that, we're going to do lemmatization and stemming. So after that, we're going to token the words and create a data frame. So it's good for analysis. So we're going to search for most trending words. Like the most repeated words are like new, Google, Apple, video, report. So new can be like new iPhone or like new Galaxy phone or anything, or like new video or like new pop album. Anything can be from new. So the Google and Apple, obviously, they would be like the most uh, dominant in the industry. And after that, so in the entertainment category, new star video. So as we said, new can be new pop album and everything. So in the medical sector, Ebola, cancer, health, new virus. So these might be like trending posts because there's a Ebola outbreak in US at that point of time. So this is a word cloud representation of the tokens, the most popular words. So the most popular words gonna be like in big size, and the words gonna be like in the smaller size. So we can see that Game, Tron, Samsung Galaxy, Kim Kardashian, Miley Cyrus. So the report, these gonna be like most trending articles, say at that time. So the models I used on my text data, logistic, naive base, decision tree, random forest, and SVM. So logistic regression, so I got 94.3% accuracy. So that is like too good to be true. So I did check the confusion matrix and it looks good. So I went for a cross validation just to be like sure. So I got 94.2. It's similar to the accuracy, so it's good. So for the naive base, I got 92% accuracy, and I just wanted to make sure that it's not overfitting. So I went for a cross validation that is also 92.2%. So I thought it would be like higher than logistic regression, but it is almost the same. So decision tree is like 54.9%. I didn't expect that to be like that low, but I thought it would be low because it is a text data and multi-class, and that too with too many rows. I thought it would be too complex for a decision tree. So for the random forest, I got 93% train accuracy, but I got 83% text accuracy. So with the cross validation, I got 81%. I thought it would be more than decision tree. Obviously, yeah, that's why like it is more than decision tree, but it is not as good as the other models. Moving on to SVM, so I got a train accuracy of 97 and test of 93, and I got a cross validation of 93%. So it's not overfitting. So you can see the comparison chart. So the random forest has slightly higher train than the test, and the rest of the things are like almost equal. The train and test are like almost similar, and the cross validation also is similar. So the data is not overfitting. So my next part of the project is to retrieve stories using WebLink, which is provided in the dataset. So there's like a sample code for that. So it's going to compare with the like BBC News, Euronews. If it is the magazine name is that, then it's going to go into the loop and it's going to retrieve using a HTML link. So so I changed the way I'm going to approach the problem. Initially, I tried retrieving all the stories from top 10 magazines based on the number of articles. So I thought I would get like a good amount of data to work with. So that didn't happen, that didn't work out, and I changed my approach actually. This is because like 7 out of 10 magazines are not active, and the other three magazines have like 3 or 4,000 articles. That is a huge amount of the articles to work with. But the problem is each magazine is 10 to each sector. Like one is in science and technology, and other is in medical, and others in business. So there are no like common and intersection points. So this became a huge issue for me. So instead of just going for like top 10 magazines and downloading the articles, I thought of like going for a issue and just downloading everything, who like downloading the magazine articles, who like how do I say that? So downloading the articles which are published on that issue. So with this, I can get like enough data on a particular issue to work with. So I thought this would help me to gather more data points on that issue, on a specific issue. This is how a HTML page looks like. So when you inspect the element, you can just get a class and class type. So in this, it is article body underscore body, standard article body underscore body. So you're going to retrieve that manually because each and every HTML page has different class items. So you're gonna retrieve that manually, and you're gonna put that into the beautiful soup parsing. So this will help to parse that and retrieve the information, and you're gonna send that into the dataset. So, but the problem is most of the websites are not actively supporting the articles because the news is from 2014, which is like 6 years from now. So after retrieving 30 articles of on a similar issue, as I said, I found out that only 4 of the 30 articles are actually having data, and the other 26 articles are inactive, and the data couldn't be retrieved. So this makes like 85% of the data is inconsistent. So it's more like producing meaningful observations with such missing data as like quite unrealistic. So the conclusions, most of the targets are achieved like text cleaning and observing trends and model creation. So meaningful insights are drawn from the text data to prove initial assumptions like US is the most used word, and stock would be in the top five in the big business sector because that is like most used word to represent any exchange or like any crash or anything. So Ebola and its cure is most trending news in the medical sector because there's an outbreak. Sorry. So model accuracy is more than 90%, which is more than my target. Actually, I aimed for 80 to 85%, more than 90%. I'm happy with that. So basic techniques like logistic regression got more accuracy. That is one of the like unique news because basic techniques like logistic regression is like always overlooked because decision tree and random forest would always like most preferred search models for many people. So news retrieval cannot be happening because the data is not sufficient. So I couldn't achieve one of the goals because I couldn't get the data for that. And as I said, with 85% of the data missing, it is highly unrealistic to work for meaningful observations. And thank you so much. This is my mail ID. Feel free to ask for like approach me for any doubts or feedback. I would appreciate that. And everyone stay safe at home. And thank you so much for listening.